So you getting the hang of this yet? This is exactly the same stuff we've been doing all the time. Take a look at this question. Again, what is the A value up front here? Well, it's 1. Look at this. The B is -2. The H then is going to be -1. And the K works out to be 3. So what did you do? Well, I stretched it and reflected it horizontally. I moved 1 to the left and 3 up. Okay, so horizontally, what did I do? I stretched it by what factor, though? Stretch by a factor of 1/2, and I reflected. Now, when you're doing a horizontal reflection, you're going this way. Guess what axis you're doing? You're going across the y-axis, so reflection across y-axis. Oh, interesting. Vertically, all I did was went up by 3. So you know what I'm going to do? I'm going to go right into the mapping notation for this because I think that's got to be the easiest way to do this. Okay, let's go. Mapping notation. Here it is. Okay. Right down to the bottom of the question. Mapping notation. So you're going to take any point x, y. Now think about this. This is going to transform. Remember, you did a horizontal by 1/2 and reflected it. That's all your x values. You're going to go to the right horizontally by -1. Okay, so, you're going left, I should say, by -1. So you're decreasing. And vertically, all you're doing is going up by 3. Okay, so let's take a bunch of points. Same graph as before. I'm going to look at that point right there, which is our favorite point, 0, 1. Let's see what happens to this guy. Well, this guy will become 0 goes into the x, -1/2 times 0 is still 0. I'm going to have now a -1. Nice. My y is going to be up by 3. There's my new point. Remember the other points that you had up here? Go to your basic formula, which was 1/4 to the power of x. Do you remember that? And start putting numbers in. If this is x equals to 1, there it is at 1/4. So you can now go and say 1, 1/4 and throw it in there, and let's see what happens to this mess. Well, x is 1, so this is going to be -1/2 -1. So if you think about this, this is -1/2 or -1.5. Okay? Y 1/4 plus 3, this will be 3 1/4. 3.25. There's your new point. And you can go on the graph now and go to -1.5 and actually plot it. Okay, so let's put these into a nice little form right away. But I want to do one more before I go and take off and start plotting points. I want to go out and I want to do our other Old Faithful, which was right here. I'm going to go y equals to -1. Or x equals to -1. You flip this around, of course, this is going to give you y equals to 4. Okay, so here we go. At -1, this is going to be +4. Let's see what our mapping tells us that's going to happen to this guy. Okay, so -1 times -1/2 gives you a +1/2 -1. This is going to be -0.5. 4 plus 3 is going to be 7. Nice. Okay. We're good. Let's throw everything on this graph here. Let's throw our new points on this graph and see what they look like. So starting at -1, I'm going to go all the way up to 4. Okay? -1, 4. So -1, 4 is right here. Oh, look at that. Invariant point. Interesting. Interesting, interesting, interesting. Okay? Next point is going to be -1.5, 3.25. -1.5, 1.5, 3.25. 3.25 looks like it's about there. Okay, there it is. And our third point is going to be -0.57. -0.57. So -0.57 looks like it's going to be around there. So look what our graph is going to look like. It's going to come down this way, and away we go. Now, I'm going to stop there because I don't know where my asymptote is. Well, actually, I do. Right there. Our asymptote started at 0 and now is transformed 3 units up. So I know my asymptote then has to be here at 3. So this is going to come around this way and just going to curl out that way. That's what my graph is going to look like. Woo! Interesting looking thing, eh? So, transformed images, well, we did all the mappings down there. Domain, X is an element of R, as always. Range, your Y has to be greater than, not equal to, almost made a mistake there, has to be greater than 3, right? Your horizontal asymptote would be Y equals to 3 then. Your x-intercept, I wonder where this is going to be intersecting. Well, think about it. If you got a horizontal asymptote, this guy ain't going to come anywhere near the x-intercept. So that does not exist. But I want to algebraically find out my y-intercept. Okay, simple. I need some room to do that. Here, let's go down here and let's write some things out. Okay, here we go. So our original formula was y minus 3 equals to 1/4 minus 2x plus 1. Do you remember? Okay, y-intercept happens when x is 0. So this is still y minus 3 equals to 1/4. That's 0 now. That'll be to the minus 2. 0 plus 1 is 1. 1 times minus 2 is minus 2. So this is y minus 3 equals to, flip it and square it. So this is now going to be 16 plus 3 plus 3. Oh my goodness, y equals to 19. So my intercept is going to be way past this, way the heck up here at 19. That's the intercept. Interesting, hey? Okay, so now you see how to do all of these transformations, and they are no different than before. The big thing to remember is SRT. Yes, that's going to save you.